All right, ladies and gentlemen, we are on lesson 520. We're going to use visual models to add two fractions that have related denominators, but not necessarily the same. So, can I add a banana and an orange to get two banana oranges? Well, no, we can't. But what could we call them? We know that a banana and orange have something in common. What's their common denominator? Well, if you said fruit, you are correct. So then I can add it up and I have two pieces of fruit. So even though I can't say I have a banana orange, I can come up with something common, which is fruit. So what I want you to do is I want you to write down 1/3 plus 1/6. So our units are different, our denominators are different. So what we have to do is we have to figure out how to get the same denominator. Now, you guys know how to get common denominators. You can make these two have common denominators because we know that 3 is related to 6. It just takes times 2. But what we're going to do is we're going to use some tape diagrams so we can represent it and you can see what it looks like. So everybody draw two tape models, one on top of the other. Make one 1/3 and make one 1/6. Pause while you do this. So these are the two tape models you should have had. I made my thirds first, and then when I did my sixth, since 3 is half of 6, I made my third lines, and then I cut each of those in half. They're not perfect, but they're close. That's why we actually need to learn how to use our multiplication and division to make common denominators, as our drawings are not always perfect. So how do I turn thirds into 6? Well, I can just cut these right down the middle. And that shows me that I have no longer 1/3, I have how many? 6. 1, 2, 3, 4, 5, 6. So I have 2 6. So what that means is that 1/3 is equivalent to 2 6, which you guys already knew, because 1/3 equals how many 6? 3 times 2, what you do to the bottom, you do to the top. So what we're really saying here is 2 6 plus 1 6, which is pretty easy to solve now. It's equal to 3 6. The next thing I want you to look at is I want you to create 1/2 plus 1/8. Again, two tape models underneath, one representing half, one representing eighth. See if you can figure out how to cut it so that we have common denominators. If not, that's okay. I'll walk you through it. Pause while you do this. So what I did originally is I had 1/2 colored in. That's what I should have left there without putting my orange marks, so ignore my orange marks. I have 1/2. I had 1/8. Well, I know that 2, if I count my multiples, I get to 8. So I wanted to make this into eighths so that they were both with a denominator of 8. So how many eighths does 1/2 equal? Well, once I split it into 8 pieces, 1, 2, 3, 4, 5, 6, 7, 8, I realized that I had 4 eighths. Pause if you need to go ahead and draw your lines so that you have the same thing that I have. If you don't need to pause, you can go ahead and do your 4 eighths plus 1/8, which equals 5 eighths. And you might have already had that. So again, we're getting that common denominator. We went from 1/2. I want to know how many eighths that is, because I know that when I count by 2's, I get to 8. 2, 4, 6, 8. 2 times 4, 1 times 4, 4 eighths. Equivalent fractions. That's why we spent so much time on it. You've noticed with these ones that we just did, they were all unit fractions. We're going to get a little more complicated now. We have 2/3 plus 3/12. I would like you to make two tape models, one representing 2/3 and 1 representing 3/12. Remembering that 12ths, your pieces will be smaller because the larger the denominator, the smaller the pieces. Good job. Go ahead and pause while you create 2/3, 3/12. If you want to go through the whole process, you can, but I'm not going to this time, I promise. Pause. If we were comparing which one was larger, you would definitely see that 2/3 is larger than 3/12, because I only need one more third to get to a whole, and here I need a lot more 12ths to get to a whole. 9 to be exact. So what we're going to do is we're going to ask ourselves, well, what does 3 have in common with 12? Well, I know if I count by 3s 4 times, I get to 12. So I'm going to cut my thirds so that I have 12 pieces, just like I did here. So I know that these are 12ths, so I'm just going to steal these lines. So that way, my lines are right where they should be compared to the diagram below. See how I'm stealing those lines? When I do that, I see that I now have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And out of those 12 pieces, I have 1, 2, 3, 4, 5, 6, 7, 8 shaded in. So we can say that 2/3 equals 8/12. And again, you could have figured it out. You could have said 2/3 equals how many 12ths? 3 times 4, which you do to the bottom, you do to the top, and you get 8/12. There's my equivalent fraction. So it equals 8/12. So if I say 8/12 plus 3/12, I have 11/12. I have almost a whole. The next thing I want you to do is I'd like you to draw 1/6 plus 3/12 with a number line. Figure out what your endpoints are. Would it be between 0 and 1, 1 and 2, 0 and 2? Pay attention to your fractions to help you out. I'd like you to first plot 1/6. Go ahead and pause while you do it. This is what yours should look like. I chose my endpoints 0 and 1 because these are both less than 0 and a lot less than 0. Or, sorry, these are both less than 1 and a lot less than 1. So I knew we wouldn't be passing that 2. So I plotted my 1/6. Well, now I have to figure out where the 12ths are. So I'd like you to write a dotted line or a different colored line to represent 12ths and label your 3/12. Pause. So what we're going to do now is we're actually going to add 1/6 plus 3/12. So I would just say that's worth 1 because it went from 0 to 1/6. Now I need to add 3/12. Well, we know that these orange lines plus the gray lines equal 12ths. 1/12, 0/12, 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12, 10/12, 11/12, 12/12. It's 1. So now I'm going to hop smaller. So 1/6, and then 1/12, 2/12, 3/12. And what I have to figure out from there is what is this point? Well, it's not on a 6th line, is it? No, it's on one of the 12th added lines. So let's start here. 1/12, 2/12, 3/12, 4/12, 5/12. So 1/6 plus 3/12 is 5/12. If I had found an equivalent fraction for 1/6, let's look at this. How many 12ths is that? 0/12, 1/12, 2/12. So 2/12 plus 3/12. Oh my gosh, look at that. They're the same. 5/12. Your job now is to get a partner and work on the problem set. I will tell you that the problem set asks you to use tape models and number lines, but if you show me a few examples of that, then you can go ahead and move on to what I showed you originally, which is getting that equivalent fraction in order to add it. So whatever way works for you. number models or tape models, number lines, or multiplication to get your equivalent fraction so you can have common denominators. Good luck.